So in this problem on binomial distribution, you'll be told in a binomial experiment of 11 trials, the variance was found to be 1.76, isn't it? If the probability of success in the experiment does not exceed 30%, determine the probability of obtaining at most two success, isn't it? So first thing you need to know is how to define a binomial distribution, isn't it? The binomial distribution has two possibilities occurring n times, isn't it? So it means in the binomial distribution, we have the p plus q raised to power n to b. The whole of that gives you the whole range of a probability measure, which is 1, by definition of a binomial distribution, isn't it? So you've been told 11 trials, meaning n, you've been told n is equals to 11, isn't it? So here n is equals to 11, then your p is the success, isn't it? And your q to be the failure. Are we together? Now, before we define, we are not, first of all, let us not divide p to be the success and q to be the failure. That definition is going to be made once we've seen which one does not exceed 30%. So if p does not exceed 30% from the problem we are going to handle, then p becomes the success, isn't it? If q does not exceed 30%, then q becomes the success. Meaning those definitions we make after we've obeyed the rule here, isn't it? Because here they're telling you if the probability of success in the experiment does not exceed 30%, meaning the value of p you are going to take to be that one that does not exceed 30%. Are you getting the argument? Are we together? So let us start. What have you been told? You've been told the variance was found to be 1.76. And how do we define the variance of a binomial distribution? The variance of a binomial distribution is given by NPQ, isn't it? So this variance NPQ, you've been told it is 1.7. And remember n you've been given, isn't it? What have you been given? Substitute what you've been given. So when we are doing the substitution, look at this. In binomial distribution has two possibilities. It means when you have p, you know q, isn't it? Meaning if p is 1 over 3, then automatically q is 2 over 3 because p plus q is supposed to be 1, isn't it? So it means if p plus q is equals to 1, then it means if you substitute 1 for you to remain with the maybe p only, it means what is q? It's going to be 1 minus, isn't it? So when we do the substitution, n is 11, then p, then q is what? 1 minus? So that we only have one variable to solve the equation. See, it is easier to solve the equation when we have only one variable. It's to be equals to what? 1.76. So can you divide both sides by 11 to make it more simpler? We now have, if we divide both sides by 11, we have p into 1 minus p to be equals to, this is divisible by 11. 1 plus 6 divided by minus 7 is divisible. What do you have? 0.116. So open this bracket, p times 1 is p times p is equals to 0.1, isn't it? So this is a quadratic. So can you rearrange it? Minus p squared going to the other side, it is positive p squared, isn't it? So we have positive c squared plus p going to the other side, it is minus, isn't it? Then the other side we have plus 0.16 to be equals to, meaning here what I've done here, this side I've remained with 0 minus p going to the other side is p squared, p going to the other side is minus p, and the other side we already have plus 0.16. Then I've just swapped, isn't it? Are we together? So what is the value of p? You solve the quadratic equation. If you are using the right calculator, go to quadratic. We'll give you the answer direct. If you are using the right calculator, go to quadratic, you go to the calculator, then you go to the setup. So if you go to the setup, you see equation is number 5. Choose equation number 5. Have you seen number 5 where we have equations? Are we together? So from here you can see the quadratic equation is in the form ap squared plus bp plus c is equals to 0, isn't it? So what is your a? See, your a is the coefficient of b squared, which is 1, isn't it? And what is your b? See, your b is the coefficient of b, which is negative negative 1, isn't it? And your C is the constant term, which is positive 0.16, meaning C is 0.16. So what are the solutions of P? So go to the calculator. Have you chose equations? So quadratic is number? Which equation is quadratic there? Number 3. So you can see number 3 is ax squared plus bx plus c is equals to 0. That is quadratic, so choose number 3. So there it will tell you to put in the value of a. So key in the value of a 1. Then you press equal sign to put it. Then you press in the value of b, negative 1. Then you press equal sign to key in. Then you press in the value of c, 0.16. This class use the right calculator for engineering mathematics. Press equals to give the value of c. So after that, if you press equal sign again, it will now start giving you the answer. So equal sign, give me the first answer of p. 4/5. Then give me the next value of p.
1/5.
So p1, p2, 1/5. So if you look at this, p has two values because a quadratic is having two solutions, isn't it? So out of these two values, one is p, one is q. So which one is p? The one you should take to be p is the one which does not exceed 30%. Are you seeing that? Meaning if you multiply 4 or 5 by 100%, what do you get? 80%. If you multiply 1/5 by 100%, what do you get? 20%. And you've been told P does not exceed 30%. So if P does not exceed 30%, if P does not exceed 30%, then it is a clear implication that P is 1/5. Meaning P is not 4. P must be one of them. If P is 1/5, then this one is Q. Are you seeing? When Q is 4/5, P, you choose the one which does not exceed 30%. Are you getting the implication of that statement?
Yes.
Are we together?
Yes.
So, remember, I have not solved this thing with the quadratic way because those are waste of time. Nobody asked you to solve a quadratic equation here. That is why we are using the calculator, one of the requirements, isn't it? And we are using the right calculator. So if you don't have the right calculator, maybe you are here to waste time. And that is unacceptable. Okay? So, if you found P to be 1/5, what do they want you to get? So, if P is 1/5, what is now Q? Q is the otherwise 4/5, isn't it? Or just 1 minus P. You get the otherwise, isn't it? So, having found P and Q, you can now go back to get, what do they want? The probability of attaining at most to success, isn't it? Can we now get that probability of at most to success? Now, this is how to do it. You don't need to waste time expanding that thing, isn't it? At most, just come here and write at most. Before you write that at most, just start with our problems. No outcome, isn't it? See, no outcome is the power of P is 0. Because we are dealing with success, meaning P is the reference. Are you getting the point? So when they say at most 2 failures, meaning Q is now the reference, we are now looking for the powers of Q, isn't it? Because in our case, P is defining the success. So when they are talking about success, we are looking at the power of P, isn't it? So the moment they say at most 2 failures, meaning Q is defining failure, so we are looking at the power of Q. Are you getting how to deal with binomial? Are we together? So when they say at most 2 success and P is defining success, then we are looking at the power of P. Is that understood? Because there are instances when Q also has a power of 0, but we are not interested in the failure, isn't it? So at most 2 success, no outcome, because this outcome is now what is defining success. So instead of saying no outcome, you can talk of no success, isn't it? Success is the power of P. So no success is when power of P is 0, isn't it? And our N is what? N is? So it means it is N combination 0, isn't it? Combination 0 because no for 0, isn't it? N combination 0, and our P defining success is now what is to power 0, isn't it? So when P is to power 0, it means Q is to power, because the X power is 11, and the total, if you add the 2 powers, you must get 11, isn't it? Meaning when P is power 0, Q is power 11, isn't it? Yes. Then you now move exactly one outcome. Exactly 1 means 11 combination, because our N is 11, isn't it? Are we together? 11 combination 1, then In this outcome, we are now taking it to be success for us to deal with P, isn't it? So exactly what success? P is to power 1. When P is to power 1, Q is to power? Because if you add the two powers, you must always get 11, isn't it? Then you move exactly to success. This one success means you concentrate on the power P, of the power of P. Is that okay? Are we together? So exactly to success, you have 11 combination, then P to power 2. When P is to power 2, Q is to power? Because the sum of the two powers must be the total power you have there, isn't it? Then move again, exactly 3. Exactly 3 success is what? 11 combination 3, P raised to power? Q raised to power? 8. Now can you substitute and give me these values? Remember where there is P, you are putting the value of P, 1 over 5. Where there is Q, you are putting the value of Q, 4 over. Meaning if you are getting this, you simply go to the calculator, 11 combination 0, in bracket P, P is 1 over 5, then you close the bracket and you raise it to power 0. Then it is times Q, Q is 4 over 5, then you raise it to power 11. So what does the calculator give? You are substituting because you have the values of P and Q. Are you seeing that? Are we together? So what do you get to be no success from the calculator? N combination, 11 combination 0, in bracket 1 over 5 raised to power 0, then times 4 over 5 raised to power 11. Use the right calculator. I don't know how you are surviving with this kind of calculators here. You found 1, isn't it? You found 1. Q raised to power 11. 4 over 5 raised to power 11. But you can never get 1. Buana. Omera, remember this? Put multiplication sign between here so that the calculator don't see it at 0. Have you placed the multiplication in between here? Meaning, what you want to put everything inside this bracket. Can you put everything inside this bracket and give me the value I found there, 0.085? Have you placed everything inside? Even if you remove that multiplication sign and you put everything inside this bracket like that. Weka kila kitu kwa bracket yake. You see, those bracket means a lot, isn't it? Zero? Are you seeing? So always follow what I do here. When I put this bracket does not mean I'm mad. It means there's a procedure in everything, isn't it? So you found 0.08? 0.0859. I move to the next one. See the next one, you only come and substitute this, isn't it? Are we together? Are we together?
Yes.
Good. So what do you have? The next one you have in bracket 11 combination 1, close the bracket, open the next bracket, P is 1 over 5 to power 1, close next bracket, open bracket, 4 over 5 to power 10. What do you get? 0.236. Are we together? Yes. Because here we are talking about at most 2. At most 2, we only need few of them, maybe 1, 2, 3 only. Then we use them, isn't it? I get this other one using the same procedure. 11 combination 2, then P is 1 over 5 to power 2, then Q is 4 over 5 to power 9. What do you get there? 0.2953. Then this last one, what have you found? You don't even need to do very many of them. Maybe 0, 1, 2 is enough. What do you get? 0 point? All these things must be 0 point, 0 point, 0 point, because if you add all of them, you're supposed to get 1, isn't it? Are you seeing that? 0 point? 1, 5. So once you get some few of them, you now go to answer the questions, isn't it? So what is the first question they want? At most 2 success. So you come and write here at most 2 success. So when you talk about at most 2, meaning 2 is the maximum you can reach, isn't it? So at most 2 success means either no or 1 or 2. At most 2 the maximum is 2, meaning you can get a 0, no success, or 1 success, or 2 success. That is at most 2. Are we together? So you start 0 means no success, isn't it? Are we together? 0 means no success. So what is the probability of no success? 0 point, you found it is 0 point? 0.0859, isn't it? Then or means what? The addition low probabilities, isn't it? Then 1 success, what have you found the probability of 1 success? 0.2362. Then or means addition low probabilities, isn't it? Then 2 success, what have you found to be exactly 2 success? 0.253. So what is the whole of this probability is now defining at most 2 success. Either no success or 1 success or 2 success. That is at most 2, isn't it? Good. So what do you get here? 0.6174. Are you seeing that? So it means when somebody asks you at least 3 success, meaning 3 going on once, isn't it? See, 3 going on once, it means will be 1 minus what is left behind, isn't it? So that you don't do a lot of operations and this, you can just make it the subject of the formula, isn't it? Very good. So that is how to handle cases of binomial distribution. Are we together? That is how to handle cases of binomial distribution. You know, today we are just introducing